are finally at our first episode of Math in New Era. Today we're going to talk about exponents. It's a common topic in math, but we're going to explore it even further in this video. Wait no more, let's get started.
In an exponential expression, the big number is the base, and the tiny number on the top right corner is called the exponent. So there are common laws of exponents that we often encounter, and we know that they all should have the same base if we would like to operate their exponents. The exponent can be added, subtracted, multiplied, and divided when they have the same base. Let's take a look at how those work. Common Law 1. The addition of exponents. If we multiply two exponential expressions that have the same base, you can add the exponents together. Like if we have 2 to the power of 2 times 2 to the power of 3, multiplying them we get 2 to the power of 5. This is the same as multiplying 4 with 8, which is 32. Common Law 2. The subtraction of exponents. If we divide two exponential expressions that have the same base, the exponents can be subtracted. If we have 3 to the power of 4 divided by 3 to the power of 2, we get 3 to the power of 2. Sometimes though, the expression with the smaller exponent is written first, and a negative exponent results. If we flip the order of our example, dividing 3 to the power of 2 by 3 to the power of 4, we get 3 to the power of negative 2. That negative power can be made positive by placing it as a denominator, placing 1 as the numerator and 3 to the power of positive 2 underneath. Other times, their exponents cancel out and the power of 0 results. Recall that when any number except 0 is raised to the power of 0, the result is always 1. Common Law 3. The multiplication of exponents. Next, exponents can be multiplied. Before, when there are two of the same bases, you add the exponents together. Now there's only one base, but two exponents, one outside the parenthesis and one inside. If you see this kind of expression, you can multiply them. If we have 2 to the power of 3 inside a set of parentheses with the power of 2 outside, we can immediately get 2 to the power of 6. Common Law 4. Division of powers. Similar to the previous law, the set of parentheses represent until which term the exponent outside affects. Division isn't very commonly written. However, if you see fractions as exponents, it means to divide the exponent. You distribute that fraction, multiplying them to the terms inside the parentheses. Any terms outside the parentheses are not affected, meaning you shouldn't apply that exponent onto it. Division of powers also means to root the expressions that are affected. The denominator becomes the root factor outside the root sign, and the numerator becomes the power placed inside of the root sign. We call this a fractional exponent. There are less common laws that applies when instead of the base being the same, the exponents are the same. We're going to discuss this next. Uncommon Law 1. Addition of the same power. Adding expressions with different bases and the same powers involve a certain formula. A quick way to remember it is that first parenthesis is the first base plus the second base, and the second longer parenthesis contains the first base to the power of 1 less than stated, plus the first base to the power of 2 less than stated, multiplied by the second base to the power of 1, and terms continue to be added, while the power of the first base decreases and the power of the second base increases. It stops when the first base's powers has finished, leaving the second base alone. For addition, the odd numbered terms on the second parenthesis should be negative when the stated power is an odd number. A simple example of this is when you expand a plus b cubed into a plus b, a squared minus ab plus b squared. Uncommon Law 2. Subtraction of the same power. Similar to addition of the same power, subtracting exponential expressions with the same power involve the same formula, but with the first parenthesis containing the difference of the two expressions, and the second parenthesis contains the same as addition with the same powers, but all terms are positive. An example of this is expanding a plus b cubed into a minus b, a squared plus ab plus b squared. Keep this in mind because we're going to use this concept to answer last episode's quiz question. Uncommon Law 3, multiplication and division of the same power. For this last law, you can basically merge two exponential terms together when you see that they have the same powers. You can directly multiply or divide the numbers inside the parenthesis, then add the power outside. For example, you have 3 to the power of 3 multiplied by 2 to the power of 3. Then it can simply result to 6 to the power of 3. You can see that it results the same with calculating it manually, but is simpler and somewhat faster. The last uncommon thing to see is an exponent on an exponent. In these cases, you should solve the furthest exponent first, like when you have 2 to the power of 3 to the power of 2. Then evaluate 3 to the power of 2 first, granting you 2 to the power of 9. It shouldn't be confused by cubing the base first because that will give you 8 to the power of 2, which is not what we're looking for.
So that's it for the laws of exponents discussed. Before we end this video, let's apply them. Remember that quiz question last episode? Here it is to refresh your memories. If you would like to try it out, please pause the video and resume when you're ready to see the solution. Here's how we're going to solve it. So we have a plus b equals to 6, ab equals to 3, and we're trying to find a cubed minus b cubed. According to the law of subtraction of the same power, we can change this format into a minus b times a squared plus ab plus b squared. Now we know what ab is, it's 3 from the given, but we don't know what a minus b nor a squared plus b squared is. So we're going to try and find that. We already have a plus b here, and we have a squared plus b squared here. So we can square this to match this format. Squaring this, we have a plus b squared equals to 6 squared. Expanding this, we have a squared plus 2ab plus b squared. 6 squared is 36. And we know that ab is 3, so a squared plus 2 times 3 plus b squared is 36. Moving 6 to the other side, we have a squared plus b squared equals to 36 minus 6. So a squared plus b squared is 30. Now we found one value that we need already. Now we're going to find a minus b. So we can do the same method but in reverse. We can square this. B squared equals to, when we expand it, a squared minus 2ab plus b squared. So we have these values already. It's 30 because we found it already. Minus 2 times ab is 3 from the given. And we have 30 minus 6, 24. But this is still a minus b squared. And we only need a minus b. Taking the square root, we can get a minus b. So square root this, both sides. We get a minus b equals to square root 24. When you simplify it, it becomes 2 square root 6. So now we have this value and these values. We just need to substitute them back into our original equation. So a minus b is 2 square root 6. A squared plus b squared is 30. Plus ab is 3. We have 2 square root 6 times 30 plus 3 is 33. Multiply it, we have 66 square root 6. And that's how we solve the quiz question. So I hope this video explains exponents well. If you have any comments or suggestions, please feel free to type them down below. Next episode, we're going to be talking about the topic of logarithms. To get our mood set for that, I have another quiz question for you guys. Here it is. Type your answer in the comment section if you would like to, and the answer as well as the method for this question will be revealed next episode. Thank you for watching and see you guys till then.